All right, so we're here today talking about heating curves or temperature time graphs. And you can see I've got this example here that's a really nice big one, shows us a lot going on. So let's break this down a little bit. Remember, every time you see a plateau, so in temperature time graphs, we have plateaus and we have slopes. So every time you see a plateau, that is a phase change. So plateau equals a phase change. Now, that means the slopes are a little different. So the slopes, do a little highlight here of those. So a slope is a temperature change. And you can tell that because temperature's on the y, so the temperature is obviously changing on the slope. But notice how during a phase change, there is no temperature change. So during a phase change, there's no temperature change. Temperature stays the same. We ran out of space there. So no temperature change. Whereas during a temperature change, as you can guess, there's no phase change. So that's the first thing we need to think about. Is this is where the phase changes are happening, is on the plateaus. Now remember, there are only three phases of matter: solid, liquid, and gas. Plasma is a substate. It doesn't have a plateau. Bose-Einstein condensate, same thing. It's a substate. It doesn't have a plateau. So that means our first transformation of matter is going to be from a solid to a liquid. So that would be my first plateau there. So that's solid to liquid. And of course, that is called melting. So solid to liquid is melting, which means that my next one up here would be liquid to gas. And that is, of course, boiling. So these are my only two phase changes. I have solid to liquid, liquid to gas. There is never going to be another plateau anywhere else. So I see the full thing here. All of these here, this is a temperature change on the yellow. So here then it's just a solid, it's just a liquid, and it's just a gas. No phase change. So when that solid, let's say this is water, right? Be 0 and 100 if this is water. So you have this ice, and the ice is heating up, heating up, heating up, heating up. Let's say it starts like, I don't know, negative 10 degrees Celsius. It gets to 0 degrees Celsius, then it can melt. It is not going to heat up again until all the ice is melted. And when all the ice is melted, all that energy goes into melting it, then the temperature is going to rise again. It's a liquid, and then that liquid temperature is going to rise, going to rise, going to rise, going to rise, going to rise until it gets to 100 degrees Celsius, and then it's all going to boil. And whenever you have boiling water, remember, boiling water is 100 degrees Celsius. It will never get hotter than 100 degrees Celsius. The vapor, the steam, can get hotter than 100 degrees Celsius. That's why you can get really bad burns from steam. But the actual liquid water that's boiling will only be 100 degrees Celsius. So it will not get any hotter than that. One last thing to remember for these is when a temperature change is occurring, remember that's a change in thermal energy. So that means the particles are speeding up or slowing down. And a phase change on the plateaus, that's a change in phase energy. That means the particles are changing their spacing, but they're not changing their speed. So thermal energy, particles are changing their speed. Phase energy, particles are changing their spacing. So whenever you draw a plateau on a temperature time graph, that shows a phase change. Whenever you draw a slope, that shows a temperature change. That's temperature time graphs.